let's finish this one up. So here's your trick, right? It's hard to reduce when you have a decimal in here, right? But that's 0.5, isn't it? Can I just double the top and bottom and there won't be a 0.5 anymore? If I double 18, what do I get? What's 4.5 times 2? Now you can reduce that, can't you?
It's easier to just do that.
I know, but I'm here to teach you stuff that's not easier. Am I not? You learn this stuff, and it'd be easier doing that than trying to dig up a calculator somewhere. And you'll be smarter. Okay, let's take a look at number 2. Guys, what is it?
4.
Choice 4, right? How'd you get it?
Because you do 6 times 3.
Scale factor of 6. The original length was 3. So,
Or you can do 6 times 4 minus 6.
or just that. Okay? All right, let's go down here. Now, when you're doing this one, right, if you think about how to get the scale factor, remember, new over old. Any new linear distance divided by the old linear distance, including new rise and run over the old rise and run. So if it's a diagonal line, right, you might have to think about counting the rise and run like a slope, and you can apply the scale factor to that as well. So think about that. Read this over. So here's our center, okay? Let's take a linear measurement from that center to say point C, right? What was the original rise and run? Rise we want up to and right what? Right? So the original was 2 to 4, right? Okay. Now, what does it take to get, what corresponds with C? F, right? So now what's this rise? What's that? Well, let's not think about negative now. What's that distance? 1, 2, 3, 4. And what's the new run?
5.
Or otherwise known as 8. Okay? Okay, so how did we get this? How do we get 8 over 4, or 2 over 4 to become 8 over 4? What do we do to this 2 and 4 to make it a 4 and an 8?
Multiply by 2.
Yeah, you doubled it, right? So we know the scale factor is 2. We could look somewhere else, right? So let's take a look at the simpler one, distance from the center to A. What does A go? First of all, it's 2, yeah. Now, what does A correspond with? D, right? So what's that new distance? 4. So 4 is the new, right? 2 was the old. See how it gives you 2? Okay. So that looks like our dilation, center to 0, scale factor of 2. And by looking at it, you know there had to be a rotation, right? So it's got to be choice 3. All right. What else? I'm going to check up simple ones here. Let's go out to the next one. Read over number 4. So we can eliminate these angle measures because we know they stay the same. So what choice? It's either 1 or 2. What is it? Well, why not 3? Somebody might have picked 1, right? Because the old scale factor 3. Ah, right. Because B prime C prime is the new, which is 3 times bigger than the old.
He's an old type, so yeah.
I suppose. All right. Now let's look at number 5. Think about what we talked about with scale factor and area. Okay. So the triangle, scale factor of 3. Dilation at the origin. So we'll just make a note here. K equals 3. Let's see if we can work out which one of these. Which one do we think it is?
I'm thinking number 1, maybe. I'm thinking number 2, maybe. I said 3.
Okay. So each linear measurement in the triangle gets multiplied by 3, right? Number 1 talks about the area now, the new area, the area of the image being 9 times the original area. Yeah, where did they get 9 from? The scale factor is 3.
Yeah.
What do we have to do to the scale factor to deal with areas?
Square
We need K squared for area, which is what? 9. Let's take a look at numbers. So one's the choice, but could it be 2?
Yeah.
The perimeter.
Wait, what's the choice?
Perimeter's linear, isn't it?
Perimeter defense. Yeah.
So perimeter gets multiplied by 3. Is this linear? Okay? What about the slope? Slope is rise and run. That's all linear, isn't it? They're not square units, they're linear. So doesn't that also get multiplied by 3? Huh? So it does say 3, right? The slope of any side of the triangle. Yes, okay. This is actually different, right? What did I tell you about dilations? The corresponding sides are parallel, right?
Yes.
And they stay parallel. So that if 2 lines are parallel, what do you know about their slopes from last year? Same slope. So we can't multiply it by 3, can we? Right? If we multiply it by 3, that's a different slope. And then the corresponding sides won't be parallel. So it can't be that one. Measure of each angle. Oh, come on. Right? Angles. We know that won't work. Okay? So it's going to be choice 1. Remember, if you got to go to area, what do you have to do with a K? Square it. And if you ever had volume, what would you do with a K? Cube it, right? I probably won't see that too much, but I want it. Okay, on to number 6. What do you do? Yes or no for 6?
No.
No. Okay, we have to explain why.
Because it's getting somehow.
It's not a rigid motion, right? What's not action? Exactly what's not. We got to be clear about
A
that.
dilation.
Be careful. It could be. Let's be more specific. A dilation of a dilation of 1/2, right? So you want to be clear about that, because if you just generally say dilation is not rigid, you're implying never rigid, right? But if it's 1, it could be. So we're going to say no, because a dilation of, what was it, 1/2 of 1/2 is not, let me say isometric.
Yeah, I always say so.
Huh?
Isometric, you said?
Yeah. So corresponding sides are what? Or watch how I do this. Not congruent.
Not
Do that.
congruent.
You say not equal, right? You do it.
Why can't I say, no, because the dilation of 1/2 is not a rigid motion?
Well, they usually want you to go and explain on more detail. You understand, right?
Yeah.
Just to make it congruent, all the corresponding sides have to be congruent, right? Triangle, side, side, side. So in other words, you wouldn't get side, side, side. Okay? All right.